Welcome to the login node. This is Will. In episode 2, we assembled our compute backbone. Today, we are bringing them online. In standard enterprise HPC, management networks and compute networks are strictly wired and separated by expensive managed switches. In this $1,300 home cluster, we are using pure physical isolation instead. My laptop acts as a login node. Its Wi-Fi adapter connects to the home router for internet access. Its physical Ethernet port connects to the Netgear GS308E gigabit managed switch, though we are running it in a flat configuration with no VLANs. The four M715Q nodes and the HP Envy GPU node also connect to this switch. The HP Envy has an Intel i7 10700F and a GTX 1660 Super. We'll configure the GPU side of the node in a dedicated episode later. For now, it just needs the same OS and network setup as every other node. Together, this connection creates a completely isolated internal subnet at 192.168.50 The worker nodes have no direct physical connection to the home router. The login node acts as a bridge, the DHCP server, and the SSH gateway. It sounds unusual, but it is a highly effective way to build a secure, isolated cluster network on a budget. Let's build it. Before we configure anything, every node needs an operating system. I used the Nano KVM to install Rocky Linux on each node remotely, rotating it between machines. The Nano KVM lets you mount an ISO image and control the BIOS over the browser, so no monitor or keyboard is needed. The installation itself is straightforward. Boot on ISO, pick minimal install, select boot drive, and let it run. I did it for all 6 nodes. Let's speed through it. With the Rocky Linux installed, let's start with the login node. First, we update the system and install essential packages like Vim, Git, and GCC. Since the login node is a laptop, we have a physical problem. If I close the lid, the cluster loses its gateway. We open the login.d config file and change handle lid switch to ignore. After restarting the login.d service, I can close the laptop and stick it on the cluster. Next is the network routing. The laptop has both Wi-Fi and wired connection, and we need outbound internet traffic to default to the Wi-Fi adapter. We use NMCLI to set the route metric of the Wi-Fi connection to 10, giving it higher priority for internet routing over the wire interface. I have already applied these settings on my system, but you can find the full step-by-step commands on the blog. Now we bring the internet cluster network to life. The worker nodes need IP addresses, but they have no connection to the home router. the login node has to become a DHCP server. First, I assign a static IP to the login node's wired interface, 192.168.50 and 1. Next, we install dnsmasq, a lightweight DHCP and DNS server. In the configuration file, we define the interface connected to switch, set the DHCP range from 192.168.50.10 to 50, and point the gateway to the login node itself. I have already set the host names, but the command is hostnamectl set-hostname. There's one more critical step. The worker nodes need internet access, but they have no direct route to the router. The login node has to forward their traffic. We enable IP forwarding in the kernel and add a masquerade rule to the firewall. This tells the login node to take any outbound packet from the cluster subnet, rewrite the source address to its own Wi-Fi IP, and send it out to the internet. When the reply comes back, it routes it to the correct worker node. Let's verify. I SSH to a worker node, check that if it received an IP from dnsmasq, and confirm it can ping an external address. Because our login node is exposed to the Wi-Fi network, security matters. We need to harden SSH access. First, create a custom SSHD configuration file in sshd-config.d. In here, let's disable root login. We need to restart the SSHD service. Then we should make sure SSH port is opened using firewall-d. I also create a systemd override, so the SSH service only starts after the network is fully online. This prevents connection failure during boot, which I ran into myself. Next, we install fail2ban. Since the login node is reachable from other devices on the home network, we do not want anyone brute forcing the SSH port. In the jail configuration, I enable SSH jail in aggressive mode with a 10-minute ban time. If a user fails to log in after a few attempts, it gets blocked at the firewall level. Let's enable the fail2ban service. Now from my regular user account on the login node, I generated an ED25519 SSH key pair and copy to each worker node using SSH copy ID. I demonstrated on one here and repeat it for the rest off camera. This gives us a passwordless SSH access across the entire cluster. The login node is ready. Let's bring the cluster together. From the login node, we check the dnsmasq leases file and see the IP addresses assigned to each node. I SSH'd into each worker and use hostnamectl to assign proper host names. Back to the login node, I update the hosts file so the entire cluster can be communicated using the host name instead of IP addresses. Let's look at the physical side. Here's a Netgear 8-port switch. The cabling is functional but messy. We have Ethernet cables connecting cluster nodes. I stacked the M715Q nodes 2x2 using rubber feet with just enough airspace for basic cooling. The HP NV sits to the side. We can tackle cable management in a future episode. For now, the priority is connectivity. The most common question about this setup is performance. If the login node is on Wi-Fi, does that bottleneck the cluster? Let's look at the routing. When I'm editing code over SSH, pulling packages from the internet, or monitoring the system, the traffic goes over Wi-Fi. For those tasks, Wi-Fi bandwidth is more than enough, but the heavy lifting happens entirely on the gigabit switch. When a compute node runs an MPI job or reads data from the NFS drive on the management node, the traffic stays on the physical switch. It never touches Wi-Fi. The login node's Wi-Fi connection is only for the management and internet access. The actual compute fabric is purely wired at full gigabit speed. Someone streaming a video on a home network will have zero impact on cluster performance. We started this episode with a pile of disconnected hardware, and now we have a fully networked, secured, and isolated cluster. Every node has an OS. The login node manages traffic and DHCP, and all nodes can communicate by host name. In the next episode, we are going to mount Samsung 990 Pro as our shared NFS storage and set up free IPA for centralized user management. After that, any user account created once will work across every node in the cluster. All the configuration commands and the network diagram are on the blog. Hit subscribe, and I'll see you in the episode 4.